Hello everyone. Here in this video, we are talking about the force between the two similar poles, that is, two poles of same nature. Say for example, this is a pole strength M1, north pole. This is another pole strength M2, but that is also a north pole. The distance between them is some value like d. The total distance, the whole distance is d. Now I consider a point P somewhere in between them who is at a distance x from the pole M1. Automatically from the other pole it will have a distance of d minus x because the whole distance is actually x. Now this pole what I have kept here could be a north pole or it could be a south pole. What if it is a north pole is I'm talking now, right? So I imagined a north pole here. On this north pole applies a repulsion with a force F1. How much is that F1? According to inverse square law, we have discussed mu naught by 4 pi M1. The pole I have kept here is something like M3. So I'm calling it like M3. By separation between them is x, so x squared. Similarly, simultaneously on this M3, due to this M2 who is also a north pole, this is a north pole and this is a north pole. So on this M3, due to this north pole, there is another repulsion. Let me call that repulsive force as F2. How much is that F2? Identify M2 is between, F2 is between these two. So mu naught by 4 pi between M2 and M3. That's the new one. By separation between them is d minus x whole square. And if you notice carefully, F1 and F2 is opposite to each other. So what is F resultant is F1 minus F2 or F2 minus F1 depending on who is dominating. So resultant will be along the direction of the dominating force. What if F1 is equal to F2, that implies F resultant on that pole becomes 0. That point where that happens is called as a null point. So null point is a point where the resultant force acting on the pole is 0. So when that null point can occur? When F1 equal to F2. I know M1, I know F1, I know F2. Let me just equate them. Mu naught by 4 pi. F1 is M1 M3 by x square. F2 is mu naught by 4 pi. M2 M3 by the distance between them is d minus x whole square. So mu naught by 4 pi can be cancelled, M3 can be cancelled. What will be remaining is get the d minus x to this side. D minus x by x whole square is M2 by M1. I need to find out the location of the x. Where do I get a null point? Let's take the square root on both the sides. D minus x by x is square root of M2 by M1. So divide with x. On left hand side, d by x minus x by x is 1. Is root of M2 by M1. So d by x is root of M2 by M1 plus 1. I need to find x. So x is d by square root of M2 by M1 plus 1. That's the location of the null point. So if I have my x here, where the location is, this x is that much. That is, what's that formula we have derived? D, total distance, by square root of second pole strength by first pole strength plus 1, which automatically makes it less than d. Then that at that point, if you keep a pole of pole strength M3, it experiences 0 force. That's how I can find a null point. What happens if these two poles are opposite in nature? We will discuss it in the next video. Thank you for watching.